This is the answer to the Got It number 1 in lesson 7.2, representing a function, part 2 in the real world. All right, make sure you've tried this, got it before you watch the video. That way you know whether or not you understand it. The question says, during 1 hour of walking, you burn 257 calories. The total number of calories burned is a function of the number of hours you walked. How can you represent this situation in 4 different ways? Okay, remember the ways, just like our objective, the ways that we're representing the function is as a rule, which is an equation, a table of values, a set of ordered pairs, and your graph, which is going to be on the back of the paper right here. First, we have to figure out, what do our input, which is your x, and our output, which is your y, represent? What do those variables represent? Let's look back at the problem. It says, during 1 hour of walking, you burn 257 calories. And it says the total number of calories burned is a function of the number of hours. Remember, it's always that the output, which in this case are calories, is a function of the input, which they said here is the number of hours you walked, because the output depends on the input. Okay, you have to walk for a certain number of hours to be able to burn those calories. You could think of it like the x is the cause. Because you walked for a certain amount of hours, the effect is that you burned calories. Okay, so you can look at the input as the cause and the output is the effect. So in our case, the input is the number of hours you walked, and then you should have labeled the output, which is your y, is the calories burned. Okay, now that we labeled those, we can get our equation, or our rule. It says, during 1 hour of walking, you burn 257 calories. Okay, so your calories burned, y, equals 257 that you're multiplying by every hour, which is x. So y equals 257x. Okay, so we got our equation. Now we need our table of values. Like I said before, let's get 4 points. Okay, 4 ordered pairs so that we can get a nice solid line. If you notice y equals 257s, this is going to be a straight line. The y-intercept is going to be 0, so this is a proportional relationship. It's going to go, the line is going to go through the origin. Okay, let's label our table of values. Our input, which is our x value, is going to be the number of hours. And then our output, which is y, is going to be the calories burned. Okay, and we'll do 1 hour, 2 hour, 3 hour, and 4 hour. Okay, let me give you time to copy that. Okay, so now we need to get, what is the y value when you have your x values as 1, 2, 3, and 4. So this is when you're going to use your equation and you're going to plug in your x values. So the first would be y equals 257 times 1. So when x is 1, we have to figure out what y is going to equal. Well, 257 times 1 hour is just, you're going to have burned 257 calories. Okay, after 2 hours, we're going to plug in 2 for the hours in our equation. Y equals 257 times 2. That is going to be 514. Okay, which means after 2 hours, you're going to have burned 514 calories. 257, right? Because you had to multiply. Okay, then we have to figure out after 3 hours. So let's plug in 3 for X. So it's 257 times 3, which when you multiply that out, it's going to be 771. Okay, maybe you want to do your multiplication here on the side, at the bottom. After 4 hours, we're going to plug in 257 times 4. It equals 1,028 calories, okay, when you multiply those two numbers. Okay. Now we need to get our set of ordered pairs. All right, which, like I said before, it's kind of easy if you have your table. You could just copy the numbers in the table. So our first ordered pair is 1, 257. Our second ordered pair, representing 2 hours and 514 calories, is 2, 514. Our third ordered pair represents 3 hours, and you burn 771 calories. 4 hours is 1,028 calories. Okay, so we have our ordered pairs. Okay, after you get your ordered pairs, you can recopy them on your graph. Okay, so what was it? It was 1 and 257, 2 and 514, 3, 771, and then 4 is 1,028. Okay, we have to figure out what our units are going to be on our X and Y axis. Okay, so, well, our output, the y-axis is going to be the calories burned. That's the units along the y-axis, and then our x is going to be the number of hours you walked. That's along your x-axis. So let's label, here's my y-axis, label calories burned. And then along your x-axis is the number of hours walked. Okay, now we have to figure out what's this going to be the scale and the intervals on our graph. Okay, well, our x goes 1, 2, 3, and 4, so let's label maybe every 2 boxes you want to do. So it's going to be 0, 1/2, 1, 1.5, 2, 2.53, 3.54, maybe you even want to extend it to 5. Okay, along the y-axis, let's go by 200s. Well, we can go by 100. So it's 0, 100, 200, 300, 400, 500, 600, 700, 800, 900, and then 1,000, 1,100. Okay, let's plot our points. Okay, we're going to guesstimate it's 1, 257. So here's 1, and then so 257 would be a little bit, it's going to be between 300 and 200, but a little bit closer to 300. Just slightly, obviously. 2, 514, we're going to go to 2, and then a tiny bit above 500 would be 514. 3, 771, we're going to go up. It's going to be between 800 and 700, but a little bit closer to 800. And then lastly, we have 4, 1,028. So it's going to be between 1,100 and 1,000, and it's going to be closer to 1,000. Okay. And as you can see, this is a proportional relationship. It should be a straight line going through the origin. Okay, so it looks like I did a pretty good job of estimating exactly, you know, like the in between the y intervals here. Okay, so we just represented the same function, this real world problem, in 4 different ways. An equation, a table of values, a set of ordered pairs, and a graph. Okay, now you're going to transition into doing the digits problems online.